Okay, so we're going to pick up with 3.1. Can you believe it? You guys are officially in chapter 3. And we're going to be getting through, I think, about chapter 5 for this first term. So you guys are getting ready to hit almost the middle point of the class. So that's of the first term, anyway. All right, so you're going to learn how to solve equations, solving linear equations. What is a linear equation anyway? What word do you see? What word do you see here inside linear? Line. So these are linear equations. That means if you were to graph these equations, which you're also going to learn how to do in chapter 4, they are going to look like lines. Okay, and that's why they call them linear equations. All right, so let's flip over to start with 3.1. And we're on page 132. And you might have already had a little bit of this in pre-algebra. You guys all take pre-algebra?
I did a book.
Okay, all right, well, that's okay if you haven't because you're going to learn it here. So the way that you think about an equation, you're going to be thinking about it in terms of, let's actually read the whole official stuff right here. Hey, Isaac, would you read the part about Griffith Park in Los Angeles to start with? Because that's going to be one of the examples, I guess, possibly.
Griffith Park in Los Angeles is one of the largest city parks in the United States. It has miles of hiking trails, a theater, and an observatory. In exercises 58 and 59, you will solve equations to find the sizes of some city parks.
Okay, great. Okay, Hallie, read the part right under the picture.
You can solve an equation by writing an equivalent equation that has the variable isolated on one side. Linear equations are equivalent equations. They have the same solutions to change or transform an equation into an equivalent equation. Think of an equation as having two sides that need to be in balance.
Okay, so if we take a look at the example they're giving you here on the first thing, they're saying x plus 3 equals what? And I know you guys can do this in your head right now. You know exactly what x is equal to. But the thing I want you to envision is that there's like a balance going on here between the left side and the right side, okay? And you're going to learn what we call the algebra golden rule. The algebra golden rule is like whatever you do to one side of the equation, you have to do to the other side, all right, to maintain that balance, to maintain that equivalence. So if I add something to this side, I got to add something to this side. If I take away something from this side, I got to take away from this side. If I multiply this side, that means I'm multiplying both terms. I have to multiply all the terms on the other side. Same thing for division. If I'm dividing these terms, I need to divide the term on the right. So there's a balance that's going on between the left and the right. Okay, now the thing that you're going to do is you're going to use inverse operations to isolate the variable. So ultimately, our goal is that we're going to get x equal to something. That's solving the equation. That's what that means. It means finding the solutions of x. And the way that you're going to do that is you're going to use inverse operations until the x or the variable, whatever it is by itself. So if you're looking at addition, what's the inverse of addition? Right, and an inverse operation is something that undoes, the other operation. So if I'm looking at addition, the operation that undoes addition is subtraction, right? What undoes subtraction? What's the inverse of subtraction? Addition. Okay, what's the inverse of multiplication? Division. And what's the inverse of division?
Multiplication.
Okay, so what you're going to do is you're going to be looking at this and looking at, okay, what operation's going on here? And I'm going to use the inverse of that. So if I'm looking at here, what's happening to this variable right now? 3 is being added to it, right? So what would be the inverse of that? Subtraction. So what we're going to do to get the variable by itself is we are going to subtract 3 from both sides. Okay, I followed the old algebra golden rule. I'm going to subtract 3 from the left side because that will get the x by itself. But I have to make sure that I do the same thing to the right side, okay? Now, what's going to happen when I come down here? I'm going to bring everything down. I bring down my x, and I'm basically combining these. So I have a plus 3 and a minus 3. What does that combine into? 0. That combines into 0. That's good. I bring down my equal sign, and now I'm going to combine 5 and negative 3. What do I get when I do that? 2. Now, you could have used mental math and said, what plus 3 equals 5? Oh, well, that's 2. But you're getting used to, now we're getting used to doing this process of using inverse operations, because eventually it's going to be so complicated you cannot do it in your head, okay? You're going to have to use the inverse. You're going to have to use this process to do it. Okay, so let's take a look at this blue box. And they're talking about the fact that what you're doing here, by subtracting 3 from both sides, you are transforming this equation into an equivalent equation that actually provides the solution, okay? So, all right, so let's do x plus 6 equals 10. I know you know what that says, but let's practice our way of doing this now, which is to use an inverse operation. So what's happening to x right now is having what? What's happening on the left side?
We're subtracting 6 from...
Right, so right now 6 is being added to x, so the inverse operation would be subtraction. So you're going to say subtract 6, subtract 6. Okay, so then Hallie, what am I going to get on the left side when I do that? I'm going to bring everything down. So x, no, so I can't, remember the section before that where you can only combine like terms, okay? The x and this are not like, so those aren't getting combined, but these guys are like, and I'm combining this. So what's positive 6 and a negative 6? 0. Equals, and then I got 10 minus 6 is 4. So x equals 4. Okay? All right, now Emily. I got x equal, wait a minute. It says simplify one or both sides. Okay, this one's kind of dumb. It says x equals 8 minus 5. Okay, here you're going to just simplify this side, right? X is going to equal 3. Yeah. All right, so let's take a look at the top of page 133. Okay, so Hallie, would you, you already read, didn't you? Emily, would you read the top of 133?
Inverse operations. Two operations that undo each other, such as addition and subtraction, are called inverse operations. Inverse operations can help you to isolate the variable on one side of an equation.
Okay. And that's kind of what we just said, right? You know, that's what we were saying. Okay, so let's do example 1. Here we go. It says x minus 5 equals 13. I know you can do mental math and say, what, minus 5 equals 13, and come up with it in your head. But let's use inverse operations, okay, to practice this skill. All right, so Emily, what's happening to x right now?
Minusing 5.
Okay, so the inverse of that's going to be?
Adding.
So I'm going to add 5 where? To both sides, right? Because I got to follow the algebra golden rule. Okay, so I'm going to add 5 to both sides. Okay, Amy, what am I going to get then on the left when I do that?
You're going to get x.
I'm going to get x, and I'm going to combine these two guys, which are like terms, because remember, what's a like term anyway? Has same variable, same exponent. I can only combine things that have the same variable, the same exponent, or numbers, pure numbers. So these are pure constants, right? So I combine those and I end up with 0. And then what am I going to get here on this side?
-8.
Not negative.
Yeah,
18.
Right, okay, see, I said 8
Wait,
originally.
I thought it was negative 13.
Me too, that's what I thought.
It says negative 13.
Oh, it does 13. Oh, I put 13
Yeah.
up in the book. Oh, I'm sorry. Okay, yes. All right. Then, if you're doing that, yes, it would be, what would it be now?
Negative 8.
Sorry, I didn't write it down right. -8. Yes, -8 is right. Okay. Now, how can I tell if I did it right?
You can
Try
subtract
substituting.
I can do a check on it, and that involves substituting my solution back into the original equation. So if my original equation is x minus 5 equals -13, then I would put negative 8 in the place of x, and I would say, and I put a little question mark on there because I'm doing the check. I don't know for sure yet. Does that equal negative 13? And then I see, oh yeah, that's negative 13. That is equal to negative 13. And so now I know I've done my check. Now be careful. In the homework, you're going to be asked to do checks. You're also going to be asked to do checks like on quizzes. Make sure when you solve for the equation, you do the check if you're being asked to do the check, because you'll lose half off if you don't. Okay? That's part of following those instructions. All right, so let's do example 2. Let's see if I can write it down right this time. Negative 8 equals n minus the minus 4. Okay. Well, in this one, we want to simplify it a little bit first. Why? Why do we want to simplify it a little bit first? Yeah, Hallie.
Because there's two subtractions.
Yeah, so what should I simplify it into?
And add.
Yeah, so I was saying negative 8 equals n plus 4. Okay. So Isaac, what's happening to the variable n right now?
It's being added.
Okay, so the inverse is going to be?
Subtraction.
So we're going to subtract 4 from both sides. Okay, and then Hallie, what am I going to get?
You would get 4. Wait, what would be negative 4?
Okay, so look right up here. So
Are we going this side or this side?
With-
So this side would be
I'm going
0.
down. So first we made this plus.
Mhm.
Okay, and now we're doing inverse operations. I'm going to get the n by itself. So I'm taking away 4, taking away 4. Okay, now I'm going down.
Yes, so that would be 0.
So this is 0 here. Okay, what else? What's this over here?
That would be 4. I know it would be a 4.
No.
Is it
Okay, the signs are alike now because you're combining.
So would it be negative 4 then? Are they?
Okay, remember, what's the addition rule?
Or I. Okay. So that would be 12.
But what
Negative
sign?
12.
Negative 12. There you go. Okay, because the signs are the same. The signs are the same, so we add them and keep the common sign. Okay, so negative 12 equals, and then what am I going to have over here?
And
And this combines into
0.
0. So I just leave it as n. So n equals negative 12. All right. So what do I do to check it then, Emily?
You do negative 8 equals, negative 12.
Minus, I'm going back to my
Minus
original,
negative
minus
4.
a minus 4. Okay, and I'm saying, does that equal? Put a question
Does
mark
that
on it.
equal?
And
Then
then I
you
put a
do
plus.
negative 12 plus 4, and then
That equals negative 8. And I say, yeah, that checks. Okay. Okay, all right, let's see what we can do here. How about Isaac and Hallie? You guys do the odd numbers, and you ladies do the even. Okay, Emily and Amy, you guys do the evens. Okay, so you're
should we
doing.
work together?
You can if you want to. You can work together. So you're doing odds, evens.
Can we do it on the whiteboard?
We will. Yeah, but right now, just do it for your notes, okay? Because we'll practice some on the whiteboards. Oh, you did the check right after. Okay. Yep. Okay, good. How you doing? This is number. Which number is that? I mean, look at it too. I mean, or the it is right there. Oh. Okay, so you did the right thing here, but this is not right. This is a negative 2. And that's a positive 4. So if I put 4 pluses down and 2 minuses down, a plus and negative. That's going to be positive 2. Yes.
Oh, I
Okay.
did.
Okay. Let's see how you doing on 3. Okay, you got that one right. Okay, is this a negative 6? That's good. All right. What you guys get? 2. 4. Did you get that one? 37. Good. Are you still working on 6?
No.
Okay, good. All right. Then we'll move here and check your 5. Oops, sorry. There it is. Yep.
Oh, yeah. We can see.
All right, number 5. How are you doing? What'd you get for that? Oh, this is okay. Okay, you're close. You're doing the check right now. That's what I'm saying. Okay. Yeah, you're having some trouble with positive negatives. Okay, those ones. Okay, so remember the addition and subtraction rules. Okay, and we're just looking at it as addition. The signs are the same. You add and keep the common sign. The signs are different. Subtract, and then 1 to 1 is further away from 0. When you're multiplying, dividing, it's even and odd numbers and negatives. Okay, determine. All right. So this right here, you're combining these. The signs are the same. It's 22, but that's right. You got to keep the common sign. Okay. All right. Okay. All right. So that's pretty good, guys. All right. So let's wrap this up. 134. Okay. Okay. Amy, read the top of page 134.
The equations in this chapter are called linear equations. In a linear equation, the exponent of the variable is 1.
Okay. So I know you're not seeing the 1 on there. Okay. So what does exponent do? What's an exponent?
Multiply something to a power.
It doesn't multiply to the power. The base multiplies to itself that number of times. So if I have an equation like this, x plus 5 equals 9, is there an exponent on this x? There actually is.
Yeah,
It's just invisible. Okay, it's invisible. It's an invisible 1. Okay, so anytime you have a variable that's there with no exponent on it, you can assume that there's a 1 on there. So in other words, what does this mean? This means x is getting multiplied to itself just once. Okay, so it has a 1. We just don't write it. It's kind of like having a coefficient of 1. There's a little invisible 1 in front of there too. We just don't write it. Okay, so this is the thing, is that if you see an equation that where the highest variable in it, the highest power of a variable in it is 1, that is a linear equation. Okay, the reason is this will graph it to a line. Okay, now let's take a look at the equation. X plus 5. What about y equals 3x minus 8? What's the variable on the y? 1. What's the variable on the x? 1. So is that a linear equation? Yes. Look next door. It says x squared plus 5 equals 9. Is that a linear equation? Do you guys have your graphing calculators here? Let's take them out. Let me show you. I'm going to graph some stuff. All right, this button right here on the upper left that says y equals, that is your equation editor. That's where you can type in an equation. Now you're going to be doing, okay, you're inside the graph. So,
Yeah, I know. I did.
okay, hit second, quit. Oh, there you go. Okay. Now, I want you to put in, we're going to graph the second equation. Y equals 3x minus 8. I want you to graph that. Y equals 3x minus 8. The way you're going to do this, hit the Y button. Y equals. Does everybody see that? Okay, now you're going to type in 3x. That's a 3. Your variable button is right here. It says x, tau, rho, nu, or something like that. These are the Greek letters, but that's your variable. So hit x. This button.
I know. I hit it.
Oh, okay, you got it.
Emily, why does mine have words on
Okay, so you can have 3,
it? What?
3, and
I
then
didn't
this
do
is your
anything.
variable.
Yes, you did.
X.
I thought you said calculator.
Okay,
No,
plus,
you were
or,
messing around.
3x minus 6,
Wow.
I mean. Hit minus
Okay.
6. 3, did you find it? Oh, okay, you don't need to do the y because it's already there. So hit clear.
We're dead.
So hit 3x, and then this is your variable button. Minus 6. Okay, and then I want you to hit, you're going to hit the zoom button and then 6, which is like your standard graph.
Something's wrong with Amy's calculator.
So I put 3x.
No, you were
I don't
Okay.
play with
You're
this.
missing
All I do is
something.
make dots.
Yes.
No, you're messing with the
3x
last time.
minus 6. Okay, that's
You
why
tried
it was
to grab
3x
something
minus
like-
6.
Okay,
Yes.
well, I guess the other direction. You did.
Okay, let me see what you did.
Amy's.
I didn't do it. Why does it have words?
Oh, you're like in the statistics part. Or where the heck are you?
She did something.
No, you did it.
I don't
last
use
time.
my calculator.
You
All
did
I
it
do is
last
make
time.
dots.
Oh my gosh.
You did it last time.
What did I do?
You were playing around with it trying to graph.
No, I don't. I make
Okay,
dots.
you've got something weird sitting here.
Let's see if you can reset.
Um,
I don't.
Do you know how to reset? I have to always Google it.
Mine has a little button. that you
No,
can
it's
reset.
like something else.
I said mine has.
We'll have to do a reset on yours, okay? But this is what it's going to look like. Okay, so you go over here, you type that in,
Right.
and
Yeah,
then,
that's what
and,
it usually.
and then
looks
hit
like.
graph.
Yeah.
Yeah, I don't know.
I don't know what's right.
It's some part of the calculator I am unfamiliar with. Okay, so, all right, now, I want you to graph x squared. Okay, you're going to graph. Okay, I'm going to do something similar, but it's going to be y equals x squared plus 5. You can graph that right below.
Oh, wow.
So put that in the
Stats,
equations.
Let's see stats.
Because I was like, I'm seeing a stat plot. Here, here, sweetie, let me grab that. You go ahead and do this, okay?
Okay.
Do we just do
3x minus 6.
Yes. No, you're graphing this one. X squared plus 5. Okay.
Wait, what do we have?
It should 6 for standard graph. And after you have it in standard graph, after that you can just hit the graph button, which is this one. Oh, something's not quite right on yours. Let's see. Oh, okay. You shoved it into the first equation. So the first equation was 3x minus 6. I'm saying go down to y sub 2 and put in x squared
Oh,
plus 5.
okay.
And make sure that you get out of the exponent when you do that. So when you hit x squared, okay, see how the little cursor is bopping right next to the exponent? To get out of the exponent, hit that right button.
Okay,
And
let's
then
see.
hit plus 5.
What should be red?
That- Wait, so how do I do where if I just clear one number?
This is my calculator looks like now.
Oh. Okay. I know what I think what it is. It's a mode. You're not in the right mode.
Wait, was it supposed to be 2 lines?
Yeah, there we go. You were not in function mode.
Okay, I don't know what that means.
Okay, so this is like if you hit the modes, you were like over here in
Sequence.
sequence as opposed to this is parametric equations, polar equations, but we want function.
Okay, I probably didn't do that. I don't know.
All right, so there you
Gotcha.
go.
Hey,
All right,
this
so what does it look like? What did you get? What'd you graph? What is that thing? That's a blob. That thing. That's a U-shaped graph. That's a.
I graphed one.
Oh, okay, great. Okay, so is that linear? Is that a line now? No. What do you think? Okay, so go ahead in there and clear those off. I want you to graph y equals x cubed. Okay, graph y equals x cubed. And once you're in the standard graph, you don't have to keep hitting zoom 6. You can just hit graph. So y equals, so you go back over here. Y equals.
That was x
Oh,
squared
wait,
plus 5.
you did type something in. I don't know where it's going.
X.
Okay, here.
Sometimes I play around just to find different graphs.
I do that a lot,
If you want to, you can borrow mine.
which is strange because I never actually do anything on it.
So I'm just clearing that out. Okay, now put it in
Ooh,
cubed.
that's cute.
So x, little caret,
Okay, how do you make it do it?
Oh,
and then hit graph.
Here, let's see. Graph.
All right. What's that look like?
It looks
Weird.
like
A squiggle.
it's got some dots.
Being born when I was born, our teachers called this the disco function. That's because of the disco dance that was big in the 1970s. But it's like looks like a snake, right? Kind of like a snake. Yeah. So all these functions that have different exponents on them are not going to graph into lines unless the highest degree is a 1. If it's the highest degree is a 1, then it's going to graph into a line. And that's what we're going to start with this year. You guys are going to start with linear equations, but you're going to do quadratics. That's the degree 2. And those are called parabolas, those U-shaped graphs. Those are called parabolas.
Ooh, I got conic graphing that has parabolas.
All right, so let's take a look at this. Problem-solving plan, page 134, top of right ahead of example 3. You can write linear equations to model many real-life situations. Example 3 shows how to model temperature change using the problem-solving plan you learned in this lesson 1.6. All right, so
I got the problem.
okay, Isaac, would you read example 3?
Spearfish, South Dakota. On January 22nd, 1943, the temperature in Spearfish fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m.
And within 7 minutes. Isn't that astounding?
Wait, 7 minutes?
That's 7 minutes from 9 a.m. to 9:27 a.m. within 7 minutes.
And 27.
27 minutes, whatever. So it's still, 27 minutes. Yeah, that's less dramatic, but still very dramatic. Okay, yes. Okay, go ahead.
Write and solve a linear equation to find how many degrees the temperature fell.
Okay. All right, so they're saying, okay, the verbal model, say the temperature at 9:27 is going to equal the temperature you started with minus the amount that it fell, right? Okay, so it's start temperature. Wait a minute, it's finishing temperature, right? It's the temperature we ended up with, right? It's going to equal the start minus the drop, right? All right, so the temperature you started with was what? Oh, they said the temperature you ended up with. Oh, yeah, that's right. The temperature you ended up with is what? Negative 4 degrees, right, Fahrenheit. And the start was 54, right, degrees. And we'll say minus, and they're using T here, that's fine for temperature. Okay, all right, so we're going to solve this and figure out what we got here. Now, what do we do first? What's happening to the variable? 54 degrees is being added to it, so what are we going to do? What's the inverse of adding 54 degrees? So we're going to subtract 54 from both sides. Minus 54, minus 54. Now you got to be careful here. There's a little trick going on here because of this minus sign in front of the T. That's got to stay there. Okay, so this, when 54 minus 54, what do I get? 0. This cancels out. When I bring this down on this side, this minus sign is going to be in the front of it. I got to bring it with it. Okay?
Wait, so I don't get how we did.
We're saying 54 minus the temperature drop is going to equal negative 4 degrees.
Okay, well, what did we plus 54 instead of minus?
Well, the 54 is plus here. I mean, there's nothing in front of it, so it is positive. And now I'm going to take the 54 away from both sides because I'm trying to get the variable, this T, by itself. Okay, so I'm taking the 54 here, I'm taking 54 away here.
It would drop by 50.
But what is what is
-4 minus 54 is negative.
58?
It's negative 50.
Okay, but hold on a second. This is negative,
Wouldn't it be
and this is negative. Yes. So this is saying negative 58 degrees equals the opposite of t. So if the opposite is equal to a negative, then what is t equal to? Technically speaking, I can multiply each side by -1 here. Okay, if that makes it more understandable. So now t is positive, or t, my variable's positive, and I get 58. So in other words, think about it. We started at 54. We've dropped all the way down to 0. That's 54. And then we dropped another 4 more, right? So the temperature drop is 58 degrees because 54 minus 58 is equal to -4. Okay? Does that make sense? Now, the thing that's tricky here is that you've got this minus sign in front of here. Remember, we were saying that the minus sign, remember, this is like an individual term. This is like saying plus a negative. So that's why I got to bring that negative down initially. Okay. All right. So, how about you guys do? Just do 7, 8, and 9 all together. Okay. So basically, you're trying to figure this It's the same type of equation, but it's a different scenario. So just it says a record 24-hour temperature change occurred in Browning, Montana, on January 23rd through 24th, 1968. The temperature fell from 44 degrees Fahrenheit to -56 degrees Fahrenheit. So you're doing kind of the same thing. Temperature you ended up with equals the start minus the drop.
7, 8, and 9.
Yeah. So, but ultimately you're trying to find out what the drop was.
So would it be 44 degrees plus negative 56 or just minus?
So right up that way. So what did it end up with? Okay. So write -56. Okay. Equals. What's the start temperature? 44 minus T. Okay. Now you're going to solve that. So you're going to do the same thing here. You're going to take 44 away from both sides. Okay. So minus 44 on both sides. Okay. Now you're going to come down. You're going to combine those, right? They got the signs are the same. Hold on a second. The signs are the same. So you add on the key. So this is like putting -56 negatives down and -44 down. So you're actually going to add those and then keep common sign. Yeah, I think it is. Okay, but keep the common sign. Okay, equals, and then you're going to bring down minus T. Okay, now I need to know what T is, not what the opposite of T is. If the opposite of T is -100, then T is equal to what? 100. So T equals 100. So in other words, the temperature dropped how far?
Are you subtracting them or adding them?
100 degrees.
Okay, so
Not
you're,
100.
yeah, because then hold on a second. It went from 44 to -56, right? So did we do this right? -56 equals 44 minus T.
And then I minus 44.
Yeah.
Sides,
Minus
and I add
44.
them.
Uh-huh.
So I got 100 equals.
But this is -100.
Negative 100 equals negative T, 100 equals T.
Yes. So T equals 100. So in other words, the temperature dropped 100 degrees, right?
Yes.
Yeah.
Oh, it is. It's 100 degrees because it's gonna drop this 44 plus another 56 going down, right? Okay, all right. Does this make sense? More or less? Okay. I think this last problem is probably harder than the homework. Okay, but all right. So what do we got to grade here? We got to check. Here, let's do some grading.